All right, so welcome everybody to LLMs in Practice. So today we have a panel conversation. I'll start us off with a handful of questions for our panelists here. I'll have everybody introduce themselves as well, and then we'll go around the room. Raise your hand if you have questions. We have 2 different mic runners, and we also have some absolutely killer swag. So we have some of these Dolly stuffed animals, and we also have some t-shirts as well. So for the first, say, 15 people ask questions, we'll have some t-shirts. And so you can look as dapper as some of us do up here. But all right, so first off, I'll introduce myself, and then I'll introduce our panel as well. So my name's Conor Murphy. I'm a manager on our machine learning practice team. And so we're a professional services team. We work with all sorts of Databricks customers. I will say most recently, a lot of that has been LLM oriented. Before that, we were doing a lot of MLOps. So that means a lot of CI/CD specifically for machine learning use cases. And then more recently, we've just been seeing LLMs. So I'll allow the group to introduce themselves, but maybe we'll start with Cheng since she has the mic. And so Cheng and Sam, maybe you've recognized them from the edX course that we launched a few weeks ago. And so we have an edX course on large language models that's going to walk you through a lot of the code, the practical tips for building LLMs. And so Cheng.
Hi, good afternoon, everyone. My name is Cheng. I'm a senior data scientist at Databricks. Been here for about over 3 years, and I started NLP right when Sesame Street's characters, were all the rage, like the Elmo bird, and now I guess we're entering the Animal Farm Kingdom era. So I'm excited to basically chat with the rest of the panel over here about LLMOps.
That's great. Yeah, trying to think of a nice, but it didn't quite work out. Hi everyone, good afternoon. It's great to have you here. My name's Sam. I will be celebrating my, I'm losing my voice because we've been talking a lot for the last 2 days. I'll be celebrating my 1-year anniversary in about a month here at Databricks. Prior to that, I was at MIT doing research in deep learning and physical systems. So it's really fun to see how LLMs are really taking over everything and the amazing tools that we're building now that we saw in the keynote. I'll pass it on real quick just so we keep enough time for all the AMAs.
Hello everyone, my name is David Talby. I'm the CTO at John Snow Labs. I've been working on natural language processing for about 10 years in healthcare, so starting on the historic days when we had computers read words. And then we went into transformers and deep learning and zero-shot learning, and now in LLMs. I worked on the Spark NLP library, and now I do a lot of work on healthcare-specific LLMs and helping people actually put them in production.
Thank you, David. And Colton?
Hey everyone, I'm Colton Peltier. I'm a senior data scientist here at Databricks working in professional services. So I'm focused on deploying ML solutions for customers, everything from forecasting, and as Conor mentioned, lately it's been LLMs, lots of LLMs, so we'll really deep dive into some common use cases for that and talk about how we approach them.
Awesome, thank you. So I'll get us started with a couple questions for the panelists, and then we'll have questions from the audience as well. And so first up, I was wondering if Cheng, you wouldn't mind just walking us through what the current landscape for LLMs look like. What are some of the core technologies that you see there? What should people be familiar with? What are they really? How are people really getting started in this space?
Yeah, for sure. And we know that large language models are really not all that new, right? I mentioned about all of the Elmo bird characters that we saw before. But today we see that large language models have really hit a tipping point in terms of accuracy and in terms also of accessibility to the wide audience that we see here. We heard multiple times today that English is the hottest new programming language, and I think that has a really special appeal because it broadens the landscape of our users. We are no longer just talking about machine learning practitioners, to use LLMs, but we are also broadening the landscape to also include software engineers, data analysts, data engineers, and etc. And probably a wide range of you today over here come from various backgrounds, right? So, and even thinking about large language models, the reason why it is large is not just because of the number of parameters, but really also because of the amount of training data. If you think about on average, a human maybe reads like 80 books a year, but ChatGPT is trained on maybe perhaps more than 10 million books. And think about how many humans would that take to read 10 million books in a lifetime. So I think we are today really talking about how do we leverage these powerful LLMs? And perhaps the biggest question that's looming in the room is, when we talk about LLMs, do we want to use open source models, or do we want to use a really single big model that has proven to be accurate or effective and usable? But then the next question that we have then, how do we apply these models to our proprietary data and put them to production? And the biggest question that basically overarches the entire end-to-end system over here then is, what is governance? What about risk? What is our acceptability threshold? How much can we trust? If we don't trust these models, can we still use them in production systems? So I think all of us here today will talk a little bit more about all of these aspects in LLMOps.
Awesome. Yeah, thank you for that overview. It's true that there's a big chasm from the prototype you do on OpenAI to actually getting something robust in production. You're not going to have issues with prompt injection. You're going to not have quality issues. And so thank you for walking us through that. So the focus of this is more on the production side of things. So I also wanted to kick things over to Sam just to kind of give us a lay of the land for what does LLMOps look like? What are some of the core features of the technology stack? How does this differ from more conventional, even though it's still new, MLOps?
That's a really good question. I have a question for the audience. Who uses MLOps daily at work? Okay, who wants to use MLOps daily at work? More contentiously, who doesn't want to use MLOps? Ooh, okay. We've got a crowd here. So LLMOps, LLMs are a type of machine learning model, and so it would make sense that LLMOps, as the buzzword term now, it will probably morph more into just a different version of MLOps. I think one of the things that really changes with machine learning versus large language models is the fact that you can't retrain at whim these different models once you have detected some kind of drift in your data and you need to change the way you're serving to your customers or to your internal processes. You really need to make a decision about where do you reallocate your resources. We saw today in the keynote that now we have these GPU serving solutions that we can make use of, but that doesn't solve the problem entirely. You're still constrained by financial resources and other things as well. And so I think what we're going to have to get really good at and really familiar with are the tools like DeepSpeed that Microsoft's produced that allows us to break apart these giant models, feed them into our compute resources piece by piece, and then run analysis on that. We might also have to, as Cheng said, let go of the notion of one LLM to rule them all, and instead create these lightweight, customized solutions using, say, a really good company like Mosaic ML that I think is probably the best ML company out there, but that's just me. I'm not biased at all. And I think we'll see a lot of these different flavors come up, and then that's going to create a whole host of other problems. We saw when machine learning libraries were being built out that everyone had a different way of doing a random forest generator and all these different things. But eventually we consolidated and we found packages like sklearn that just took care of all of this for us. And so with NLP giants that already exist in this space, I think we'll look to them for their best practices to see what we should do next, both with hardware but also the different types of software.
Awesome. Thanks for walking us through that. So next I wanted to kick things over to Colton. So the question for Colton is, for a lot of folks, they're wondering about that first LLM project. And so Colton's been working on implementing one at the moment. And we kind of see a general maturity pattern that different companies follow. And so it's just like many other industries, right? So if you're a retailer, the first model that you build is usually either forecasting or churn prediction, and then you mature in your use of data from there. So specific to LLMs, what is that first use case that you've been seeing? What are some of the general approaches that people are taking for that first win that they have with LLMs?
Yeah, absolutely. It's a great question. So typically the first case that we're seeing over and over again is a search retrieval system. So customers who have a proprietary data set and they want to take that proprietary data set and they want to query it with natural language. So they want to be able to ask questions to their data and get a natural language response. And when we're approaching this for a customer, there's a lot of questions you have to kind of ask yourself. And my approach is always to start as simple as possible and to add complexity as needed. I think you don't want to bake too much complexity into a system from the beginning and it come back to bite you. So the first question you always ask yourself is, how will I store the vectors generated from my documents? And so there's options of vector libraries and databases, and there's questions of scale. So my first piece of advice would be to look at how much documentation you have and how often that documentation is changing, and then do some research around the possible solutions you can use for vector databases. Once you have that sort of picked out, you also need to pick your LLM. And there's some big questions here around privacy of your data and keeping your proprietary data in-house. So if you have a proprietary data set that you don't want to send to OpenAI or to some other third-party API, you'll have to look at how you can host your own LLM, which I'm partial to Databricks, but we do offer GPU serving endpoints where you can host these models. And so there's always that question of, can I send this data out? Can I trust the company I'm sending the data to, or should I host the model in-house? And finally, once you kind of have those components picked, there's a lot of work you still need to do around your prompt engineering and deciding on the best way to sort of iterate on those prompts and evaluate performance. So yeah, I think there's some big knobs you could tune there and a couple major components to look at. And my advice would be to approach your first use case very specific to what data are you coming from and what's the results you want at the end.
Thank you. So it's really that, like, those QA-style chatbots on your own data, that seems to be the first use case that comes up in maybe 80% of the conversations we have. And then after that, it's, you know, how do I not only query my unstructured internal data, but how do I query my structured internal data? So that's usually the second use case we're seeing. So next up, I just wanted to ask David. So first off, I just want to say at Databricks, we have a lot of respect and admiration for John Snow Labs. John Snow Labs has had a lot of historic notoriety with NLP, better NLP functionality for within Spark. So I think everybody on the team has used John Snow Labs at some point in time, so really appreciate you being here. But I wanted to ask specifically, so John Snow Labs, a lot of healthcare applications especially, but can you speak a little bit to the value of John Snow Labs, how specifically you're responding to more conventional NLP use cases, maybe using Spark and other tools, and how you're adapting those specifically for this change with LLMs?
Yep. So at John Snow Labs, I mean, our promise to everyone, to open source community, to our customers, that we will keep you the state of the art. Right? So we actually started before BERT, and then was BERT, and then there was bio-BERT, and then there were few-shot learning and zero-shot learning, and now we have LLMs. So for us, really, we're just going with that. And this is really all we do. It's a super fun job. You wake up in the morning, you read all the cool new papers, all the new libraries, you test them. What happens in healthcare, though, most things don't reproduce, and most things do not generalize. So really, one of the first things we've learned so far, we look at GPT-4 and ChatGPT and Falcon and Llama and all of those. The first thing we've learned, they suck for healthcare. They really do. And in the beginning, we thought it was just us, and we started publishing notebooks and benchmarks. Now there's a few academic papers that reproduce the same thing. So for the core use cases that people want to know about, look, I just want to do clinical information abstraction. I want to ask questions about a set of a clinical trial, a set of documents, mostly a set of patients. There's a very, very big gap in accuracy between what a GPT-4 gives you and what you can get really, which is state-of-the-art classic deep learning models. So once we combine them, there are use cases we definitely want to use GPT-based model, like question answering, synthetic data generation, text summarization. So we're focusing on those. But one of the things I think I see in healthcare, and we see this in legal as well, is that you're definitely going to have domain-specific LLMs. Because healthcare, and if you work in this space, really, it's a different language. Right? So there's a reason why you need a doctor to read your own clinical notes, because they're not written in English. Right? There's really, look, it will take you less time to learn Russian than to learn to read radiology reports. Okay, this is just how long it takes. Just see how long you actually have to go to school to be able to do this correctly. Okay, it's just a more complex and different language. So that's one thing we are seeing. The other big thing we are seeing in healthcare is compliance. And it's not just security and privacy. We talked, yes, I'm not going to send my data out. I have personal information of patient. I'm extremely concerned there. Another thing that we see in healthcare that really I haven't seen anywhere else, people are really worried about bias, about fairness, about even truthfulness, about robustness, because the problem in healthcare is if you release a product, right? It could be a chatbot, could be a medical device, could be something. If you do not do as well for white people and black people, for people who are stage 2 versus stage 4, you not just, first of all, you will get sued. Second of all, you should get sued, right? And third thing, there's even criminal liability. Okay, so healthcare is one of those very few industries where a lot of the things that, today it's, responsible, it's a great, someday maybe we should totally deal with it. In healthcare, it's very often, look, we will not have the first use in production ever, right? Before you have done all of these tests in all of this category and have proven that all of this works, right? The same way we do now with web application, we talk about, of course we do vulnerability scanning, right? And we release process, we do versioning, we do rollback. They do, we do this, we're contractually obligated, and we do this, and we actually have an open source library, we help our customers do this. Make sure that the models are actually, they're safe, they're robust, they actually do what they need to do, and it's part of your MLOps process. And honestly, I think everybody should do it. It just kind of, I think it will just take a while to get there.
Yeah, thanks for walking through that. Yeah, because it's true for industries that are that regulated, there's a different bar that you use for putting these things into production because the ramifications are significant. Okay, so we have some t-shirts. We want to get some questions from the audience as well. I have a few more questions in case we don't have that many questions from the audience. But we have our 2 runners, so if anybody wants to throw up we got plenty of questions. And be sure to tell them what your t-shirt size is. That's my incentive to get more questions. Please.
Hi, my t-shirt size is a medium. So my question is, when you have an LLM in production, right, so how often do you pre-train or fine-tune that, given that your data is changing a lot?
Great question.
Sorry, could you repeat the question a little bit?
So the question is pre-training versus fine-tuning. What are some of the trade-offs? How often are you seeing fine-tuning versus using straight off-the-shelf models?
Yeah, when your data is changing, basically you have to fine-tune because the data is changing.
Yeah, no, that's a really good question. It came up quite a bit in the last few days when we were teaching as well. We're getting really lucky that the research community is pushing so fast and quite robustly in the field in this particular space. 2 years ago, even 12 months ago, this question would be, this is going to be painful because you'll have to retrain these things or you'll just have to suffer degraded performance. With some of the innovations that we're seeing with parameter efficient fine-tuning, there's a couple of different ways you can approach this. So if you have enough data that you think my LLM, as I was saying, doesn't know this language in this sort of context, then it makes sense to use some of these processes like LoRa, where you keep the large language model more or less in the state that it was and just update a very small version or a small matrix that more or less accounts for the update in the fine-tuning that would otherwise happen when you're trying to update the entire model. You can think of this kind of like what we used to do in the old world with convolutional neural networks in the old days, where we would just freeze most of the network and then just update the last layer. You can do something akin to that with large language models, so it just looks a little bit different. But that's quite an efficient way of fine-tuning things to keep up with data as it changes. The other thing that you can look into, of course, is with the improvements that we're seeing with context lengths, you can also add more enrichment into your prompts so that it can infer more of what's going on, even if the data that it was trained on is maybe a little stale. If it's not pushing too far in the other direction of being completely incorrect, you can use that prompt to push the LLM in the right direction. But that also means that monitoring LLMs is also a really important thing to do, and more of those monitoring tools as well with MLflow and other pieces are helping that as well. So you can go either way. Really, if you don't have too much data, you start with prompts. If you end up getting more and more data, you can think about fine-tuning.
Yeah, I think, look, for a domain, you definitely want to fine-tune. So if you work within a large corporation, you have, like, can I train on my entire, SharePoint or all my product documentation? You definitely want to do that. In some cases, you will not need to retrain very often because, for example, when we work on medical research, we can just tune the entire body of public medical research once, right? And you kind of, you overfit on the whole internet, or like on the whole domain, right? And then you do not need to update as often. So that happens as well. The other thing that's happening really, like, just like you said, things are changing super fast. So I know, like, in February, we were thinking, we need to get GPUs and be able to tune a model. And then, like, 6 weeks later, it's like my team tell me, no, I just tune on my laptop, right? Because it said there's now parameter efficient tuning, and you can decide which layers you tune. And it's like, I don't even need a server, right? I just run it overnight and it's fine. And those things moved so quickly from this cannot be done to here's an academic paper to here's an open source library, you can do this in 4 lines of code. It's like, it's week by week. So I think also anything you hear here, it's like, by next week it's going to be, these are all solved problems and we'll have something else.
So for the sake of a t-shirt, maybe I should hold on the microphone. All right. So my question is, I think we are a healthcare company. So there's a lot of progress now. Physicians, they embed the patient demographic inside the chief complaint. So we got millions and millions of patients in the data. So how we can ensure that those PHI can be eliminated before we send the data out for the training. The second, I think for the LLM, even we got millions of data, millions of patient data in-house, but we still feel the data is not enough. So should we merge that with the outside large data set, I think for fine-tune for the more deep learning into it? Thank you.
Just as a quick level set for the PHI, private health information, right? So for the non-healthcare folks, it's the healthcare equivalent of PII, but please.
Yes, so PHI, yes, it's personal protected health information. Let me, if I go to the doctor writes, David came in, he complained about this and complained about that and complained about the other thing, and I also think he has this like other mental health condition, and all of that is written there. So the problem is, yes, if you fine-tune an LLM with that, then the LLM will be able to answer the question. Okay, what is David's second worst, mental health diagnosis? But also, if you fine-tune LLM, for example, if you're outside healthcare, on all the emails in your company, you're going to get all the office gossip coming out, okay? And you're going to get super sensitive things, and you don't have fine-grained controls, who is allowed to see which data. So that's something you do not want to do. And yes, in general, one thing you never, ever, ever, ever do is train or tune any machine learning model, LLM or otherwise, on PHI. Okay? With de-identification, it is pretty easy because right now we can de-identify text automatically with really like 99% and above accuracy. So you just need to actually do it. But de-identification of unstructured data is pretty much a solved problem, right? And we have like great case studies on Databricks and others, and people do that. Absolutely. Another thing, in terms of just the quantity of data, I would say it really depends on the specific specialty. So it's not just about having more patients, right? The point is you can have a lot of patients, but you still may have, in the whole San Francisco area, you may only have, 5 people per year who have a very, very specific tumor and genomic profile, right? And that's where often you rely on human experts, right? Because those are the cases where a doctor will tell you, look, honestly, for this, for this thing like we don't know, here's what I would do, right? Because another thing that happens in healthcare, very often you don't have guidelines, right? And kind of, you try to help people as much as you can, but it's not clear. So look, like anywhere, you have a lot of data, right? So if you want to ask questions about diabetics, like tens of millions of them. If it's more specific, yes, we'll just have to wait until we have the data.
So we have a LLM running in productions, and we've been sort of chunking we embed the vectors, and we just kind of store the vectors in the JSON and infer it to a data frame. And one thing that I've noticed is that the cosine similarity search time has been scaling up linearly with the size of documents. So my question is, with the announcement of the vector DB this morning, could you shed some light into what's under the hood of the vector store, and what can I expect the search time to be for cosine? Yeah, thank you.
Yeah, Cheng, you're our vector guru. I wonder if you want to take that question.
Unfortunately, they did not keep me in the loop in terms of what is underlying our vector search indexing algorithm, but I'm not surprised to hear that when you store your documents in a JSON file and the search, cosine similarity search, will increase linearly as the number of documents get bigger and bigger. So in general, a good starter algorithm for any vector indexing, as he mentioned, is not to use any vector database provider or vector database provider, basically. But as you run into this type of issues of scalability, then that's when we turn to a formal, sort of more official provider of vector indexing algorithm. So that's when like vector libraries, vector databases come in, and a lot of these vector libraries do implement general vector indexing strategies that can also help with low latency search. So there's a lot of variety of research out there. The most popular one is HNSW and with some vector compression. But this type of techniques are basically provided by these providers. And as users, we rarely need to be concerned about the details. So without knowing the underlying details of how Databricks has implemented it yet, I would say that a good starter is basically as what he said, as a JSON, implement it, save it, that vectors out into a JSON file, or even using NumPy arrays, and then you can look into incorporating additional components to your system. Sorry, that was kind of like a non-answer.
Yeah, and so that same algorithm is going to be implemented across a number of different vector databases, and that could potentially be a good place to start. Also, the team that's working on that, we acquired a company called Rubicon not too long ago. And so that was a database company that does some very fast scale up, scale down of databases. And so that's, I think, part of the edge of doing it within Databricks. Not only is it one platform, but there's also some scalability within that allows you to not have to pay for VMs and that resource when you're not using it, that sort of thing. So that might be, the features that are kind of novel to this relative to ChromaDB, Weave8, some of these open source solutions that are going to be implementing, similar algorithms.
So my question is about the healthcare again. So as a person that works in the healthcare industry, and we are working every day with sensitive data of our patients. So my question is that if we don't want to have like a chatbot or something, because we are working with the sensitive data, we don't want to share it with our model. If we only want to do like prediction or forecasting or these type of stuff, can we? Is it necessary or even efficient to use LLMs, or is it better to use like the previous machine learning models that was working fine?
I would say, first of all, if you have another solution that's working fine, please just stick with it. With LLM, there are a lot of things that are unknown. In general, they're much more expensive to run. As you said, nobody knows how to actually operate them. They're slower. There are latency issues across the board. It's just new technology. It's going to get better. But look, if you can solve something with the CNN or a random forest, you absolutely should. It's going to be simpler, faster, cheaper, easier. You have all of the tools to manage it. You should absolutely do that. One other thing I would say, in general, what you're seeing in healthcare is that people do not send patient data ever to any third-party API. That's a non-option. Even within secure environments. Usually what people want is a solution that runs air-gap, runs on-premise, they can deploy, so you know exactly where your patient data is at all time. You also want to make sure that the LLM is not tuned on the patient data. The LLM queries the patient data when it needs to, right? Because then you can have specific permissions for specific users, and then the LLM does not remember that, right? Because you do not tune it, because the LLM itself has an issue. I think definitely, a lot of the players in that space are going to go with those on-premise air-gap solutions where basically you can work without an internet connection.
One other piece on top of that. You can still use LLMs for a lot of these featureization procedures where if you have to interpret documents in some form, but then use that for prediction or generation of other things where an LLM is not really needed, just creating the embeddings for these things so you can take unstructured data and put them into a format where they can be used as structured data and then used as a regular feature vector for other simple machine learning procedures. That's also really powerful and probably underutilized because everyone's rushing to LLMify everything. So that's another solution as well.
Yeah, add on the question related to the healthcare, for the LLM and also this generation AI side, what are the proven things or what are the pathways to do the explainabilities to give people more observability how this model function and make the trust, people feel have the trust in the models?
Yeah, so in terms of trust, there are two things. First of all, we are building an open source library. It's called NLP Test. And its only job in life is to test LLM, mostly LLMs. So right now you can test 12 of them for things like accuracy, but also bias, robustness, fairness, toxicity, truthfulness, speed. There's I think 10 aspects that we test. Okay. So for example, ask a question. Okay. This patient, Mike Johnson, what happened with him? And you get an answer. Change the name to a Hispanic name, to a black name, to a Hindu name. What do you get? Change it to a female name. Okay. So the nice thing is we used to have to write unit tests one by one. With generative AI, we can generate those tests. right? So very often you can start with the core set, comes, oh, generate like 2,000 more tests, and I want to, here are the things I want to do. So that's kind of really your kind of black box testing, right? You can say, I want to see how this thing really does on this metric, and it's not, the next version is not going to production if it doesn't pass that. So I think really one of the things that we're still missing with LLM is the whole testing concept, right? It's kind of software engineering in the 80s, works on my machine, it's like, we're good. And it got us to our first generation of software. With LLMs, we really, like, yeah, this seems okay, F1 score seems okay, worked on my few prompts, production, right? This is what people are actually doing now. I think it's going to change very quickly because things are changing very quickly. The other thing that we're seeing in healthcare is when you show an answer to a person, you have to explain it, right? So I think that I just said previously, again, an example. Classic question answering asks you, what's the capital of Israel? And you say, okay, Jerusalem, cool. There's a kind of binary answers. But in healthcare, there are no binary answers, right? So if someone asks, oh, here's this patient. They have this radiology report. We want to do, what's the next action? It's debatable. Different doctors will tell you different things, right? Or very often, especially with medical research, right? You come and say, oh, this medication has this side effect, right? A doctor will say, why? Who says who? Show me the paper. What year is this paper from? How many patients was this tested on? From which country? Right? Was this repeated? Is there a meta-analysis? Right? And sometimes you can say, look, if this was a test even not on humans, this is super interesting because I'm doing drug discovery. To ask me to change how I'm treating people, my bar is much higher. Right? And different doctors come and say, no, I know this lab. It's like just, no. Right? Because also, if you look at research, you have a lot of conflicting research. Right? If you want to find research that says that sugar will help you with weight loss, there's papers that say that. Right? So being able really to come and say every sentence, like Wikipedia, here's the reference. Okay? I'm telling you this patient is such and such. Oh, why? Okay, here's where I see it. You can dive deep. That's a lot of how we see our own doctors use the system. Okay? And really, it's never, like the classic benchmark, you do a Q&A summarization, it doesn't help. A lot of it is very interactive. Right? Is I ask you something, you tell me this. What do you mean by diabetic? Right? Like, are they diagnosed, or do you just have test results? When is it from? How sure are you? Right? And that's often how medicine is also practiced. So that's part of it is really just the UI that we still need to work on.
And I also want to add that the question of observability or explainability in general extend much beyond LLM. So even in the age of deep learning, we have been talking about the same question over and over again. But we also know that deep learning, which is basically the field that is embedded within, or I should say LLM is embedded within deep learning, we know that it's known to be unpredictable. And in fact, especially for large language models, what do? They predict the next word. And just like you can't predict what's going to come out of a mouth the next time, you also can't really predict what is going to be the next token that a language model is going to output. So that means that on top of whatever, all the metrics that David just mentioned just now, we as users and also as creators of this LLMs also have to establish some sort of human acceptable threshold. Like, what is your threshold to accept the risk, to deploy this system in production? Am I okay to see maybe 1 out of 10 or 2 out of 10 errors in the recommendations for say, either the patients or any other end users? So it means that regardless of whatever models that you have, even if we have a perfect metric, just like he said, there is not always going to be 100% alignment between the model metric and also human preference. And even if you were to go to a doctor and ask for an opinion, you might also choose to go to a second doctor to get a second opinion, right? So if that's the case, then we cannot expect LLM to be perfect. So we have to come up with some threshold to determine what is acceptable for us. And we cannot expect there to be zero risk.
I want to make sure we get some questions from all over the audience. Maybe I'll hand my mic to you, and just be careful of the speaker there.
So, hi, thank you. Coming from a European bank, which is always fun, I would say, if you talk AI, we want to actually build LLMs around the environmental, social, and governmental scores. And this is something super new. So how would you implement the feedback loops that actually train the model to come up with the right answer to those questions?
Great question.
I can take a stab at it, but you might have to do a professional service engagement to get the proper answer for that. I think one of the things that LLMs necessitate more than any other data science model, I think, would be the need for human feedback. And we saw with even the release paper for GPT-4, they showed multiple versions of it behaving with and without human feedback. And one of the reasons ChatGPT is changing the way it responds to its users, rather than always just saying, I'm a language model, I don't know how to hotwire a car, blah, 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 is it's trying to make it more personable, respect the user a little more and say, that's illegal, are you sure you want to learn about that, or do you just want to learn about electronics or something else? So it's doing its best to try and be a little more respectful of the user. And I think one of the things that is really valuable to make sure that you're steering these things in a very subjective way is to gather as much human feedback as possible, even to the point of paying people to sit there and implement some of these reinforcement processes with human feedback. So I think that's a really important thing that can be adopted a lot more.
And just to tack onto that, so another approach is to have another LLM that's doing your quality control and your alignment back to those standards. And so differentiating, I mean, that's how OpenAI is working under the hood, right? One main LLM that's creating the answers, and then a second LLM that's doing the quality control. Hey, I shouldn't be talking about hot wiring a car, so I'm just going to say I can't do that. And so those more complex architectures of starting to chain together these different agents seems to be a just incredibly powerful tool to create these more complex solutions. Next question, go ahead.
So my question is about the cost considerations that someone should think of, especially when it comes to fine-tuning. I mean, you'll see all these blog posts talking about I fine-tune for like $200, which is insane. Like, it's not possible, we all know that. So besides the GPU running costs, like what else should be thinking of fine-tuning the right way, whether it is incorporating our LHF or anything else to get the most boost out of doing a fine-tuning, if that's even necessary?
Yeah, I think when we talk about fine-tuning, we're making a baseline assumption that you're going to be using an open source model. So generally speaking, we see that when you have larger data, when you have more or higher quality data, then it's worth looking into fine-tuning. But I also want to emphasize that it hugely depends also on the size of the organization as well. Like for example, I recently read a blog post that is just published at the end of May or April. It basically tries to benchmark the cost of serving or hosting your own model versus just querying against a bigger model. And they find that if you have maybe say thousands of requests querying against this endpoint, it might actually be cheaper to query from a technology provider. But if you were to have a much larger scale of requests that's sending against this endpoint, like maybe say millions of requests, then that's when you can maybe look into hosting and serving your own model. Because the chances over here is that, so I should also say another aspect, which is latency. When you use a closed source model, because you are sending your request against an external provider, your latency generally will be much higher. So the advantage of hosting your own model then is lower latency. But then so we kind of have to make the choices between how much latency would I want to accept, but also how much cost do I want to incur, but also then think about how much data do you have. So if at the current phase, high quality data samples is not what you have, then that's what you should start with first. Because if you don't have high quality data, then chances are you're going to be wasting your money on fine tuning a model.
I think we have time for just one more question. So we'll do one more quick question, then wrap up, please.
Sure. Hi, everyone. David, this is like a question for you, basically, in healthcare. So why, in the world of like right now, we have a lot of LLMs coming up. So according to you, is it like very necessary for us to use LLMs in risk stratification? Because when it comes to risk stratification, we don't have data which is like actually fit for an LLM. Usually a forecasting model or a predictive model is much better. What is your take on that? Like what kind of data would you use? Yeah,
we do patient risk stratification, so HCC coding those types of applications. Right now, without an LLM, we get higher accuracy results. In general, use cases it's for information extraction. Read the notes, extract what diagnosis the patient have, and do some calculation on top of that. That's where LLMs do not do as well accuracy-wise. Yeah, so generally information extraction is where they're not as accurate as the models we were using last year. Where you want them is really text generation, summarization, question answering.
Great. So I just have one more quick question for David. I mean, your answers were so good. Do you want to come work for us at Databricks?
Can I get a t-shirt? Let's start there.
Yeah, we'll get you a t-shirt. Well, thank you all so much for coming in. We'll probably stick around for a few minutes for questions. Maybe we'll take them out in the hall afterwards, but thank you all so much.